Hello guys, what's up? So welcome to my new video. So this one I'll be doing some different stuff. So like I also tell you that you can request in the comment below for me to explain something on a particular topic or subject that you don't understand, because this is a friend explain. So that thing that you're seeing is one of the thing that was requested for me to make a video just to answer this particular question. So this question is for 2021. So this question is coming from Examination Council of Zambia, so to say. So ECZ. So that is one of the questions there that you're seeing, and what you are seeing in front of you, that is just a structure, a simple structure of a nephron, or should I say a detailed structure of a nephron. Yeah, so I know that some of you've come across this, you know the structure, you can able to draw that, and you can able to label it. So it's just a simple thing, and quickly, without not wasting much of your time, because I want this video just to be about less than 6 minutes. So let's jump into it, and let me start answering the questions that were required of you to answer. And don't forget to subscribe, don't forget to hit the notification bell. And if you do also find this video so helpful and it gives you that revision vibe, don't forget to give us a like. So basically I'll jump into that, but let me also appreciate my sponsors. So for Node Learning Lab and Research, so this program or this video is made possible to you by the Node Learning Lab and Research. So once again, welcome to A Friend Explains, courtesy of IK Film Network. And so to just jump in, I'll start to answer this. So this was question 4 for 2021, and it says Figure 4 shows the structure of a nephron. You can see that, and we have this structure, and we've got these K, L, and M. And the question number 1 here says identify. So they want us to identify. So identify the parts labeled K and L. All right. So what are the parts that are labeled K and L? So just explore that a bit so that you can see. So K, 1 mark, 1 mark. So together, if you answer this, you're gonna get yourself a 2 mark. So basically K, all right, let me just show you again. So this K here, right? So this K here, these are efferent vessels or efferent ends, and this is efferent. So these are efferent. So I don't know if I can manage to write that. Yeah, it's pairing like that. F double F E K R, that is R there. Right, so these are efferent end or vessels, if you want to call them, just like that. Yeah, so that is the efferent. These are called efferent, right? So it starts with E. The only difference is the spelling. So these are coming from the arteries, and they carry blood at a high pressure. Now, one thing that I might want to mention is that you might recall that this question is coming from excretion. So basically, the nephron, it undergo 4 stages just for them to filter out something or its only function. So it has got 4 stages, which is the ultrafiltration. If you might recall that we have the ultrafiltration, we have selective reabsorption, we've got osmoregulation, and the last stage in the nephron is that it is selection. So under ultrafiltration there, right, so this is where we are filtering the blood that is coming with this vessel, the efferent end, right? So this is connected to the arteries. So this blood is, it is basically at a high pressure. So when it enters the glomerulus, so it enters the glomerulus, and small particles or molecules are able to filter into the pores, and they go down into the Bowman's capsule. So the Bowman capsule is something like a ball that receives what is being filtered. So basically, large molecules won't pass through those pores. So hence what we're going to have here, we're going to have water passing through, and as well as glucose will pass through, even other substances that are smaller. So substances such as red blood cells won't pass through, proteins, as well as even platelets won't pass through, won't be filtered. So that is what is happening in ultrafiltration. So, or sometimes it's also known as the pressure filtration, because the blood there is received at a pressure so that the filtration is able to take place. Then what happens, another thing, is that we've got a selective reabsorption somewhere here where it is written K. So this selective reabsorption, what happens is that substances are being reabsorbed. So useful substances are being reabsorbed from the renal tubular into the bloodstream. That is what's happening. Then we've got osmoregulation, that's just regulating the water levels in the body. And last not but the least, we're going to have the selection. So this will just be the removal of urine from the kidney through the correcting duct, which is this one. So basically that is what is happening. So I was just trying to highlight you on that. So let's go and label our L. So our L, it's simple as that. That is a Bowman capsule, right? So that is a Bow, okay, W there. That is our Bowman capsule. Okay, Bowman's. Okay, so Bowman's capsule. Yeah. Okay, so we've labeled our K and our L. So let's go to the next question. So we've earned ourselves that 2 marks. All right, so we go. So B says name 2 substances present in the fluid, in the fluid in K but absent from the fluid in L. So we've got this fluid here, all right, in the fluid K. So you can see that this vessel is labeled K, but what K is carrying is called fluid K, because this is labeled K. So basically this is blood, all right. This is blood that is coming to the glomerulus. So this is blood that is coming from the glomerulus. So when so in actual sense, what I'm just trying to say is that this is a blood. So blood will contain, we've learned about the composition of blood, right? So there are red blood cells, platelets, glucose, whatever substances, hormones, and different kind of stuffs. So now our question is, name 2 substances present in the fluid K. Okay, so let us name those 2 substances that are present in fluid K but are absent in fluid M. So fluid M is something that has been already filtered there and collected here. So ideally, number 1 will be red blood cells. So red blood cells are large molecules, so they won't pass that side. So let me just abbreviate that. I'll write RBCs. All right, so we have the RBCs, which are red blood cells or erythrocytes, if you so called. So we've got the erythrocytes. So can you see this? Yeah, so we've got the red blood cells. They'll be present in K. What else apart from that? Also we can have something like plasma protein, right? We can have plasma proteins, okay, such as antibodies, fibrinogens, all those kind of proteins. So even platelets themselves, okay, plasma protein. It's hard writing using a mouse. So we've got those RBCs and plasma protein. If you want, if it was 3, you can also add something like platelets, because they are also large molecules, hence they won't able to be filtered here. All right, so the red blood cells and the plasma proteins will be absent in liquid or in fluid M, but will be present in fluid K. Is that making sense? Right, so let's go. Give 2 reasons for your answer. So why are we saying red blood cells and why are we saying plasma protein? All right, ideally, number 1 is that this is because they are large molecules. All right, so they are large molecules. So reason number 1 is that they are large molecules. Who are we referring as to have large molecules? We are saying the red blood cells and the plasma proteins, they are large molecules. The platelets, they are large molecules, so hence they won't pass through that. Other thing is that also the reason could be the size of the filtration slot is restricted. Okay, so meaning the size also, sorry about that, the size, are you able to see that? So the size of the, okay, so here when the filtration is being done, the size of these filtration slots are small, right? It's very small, so hence it doesn't allow particles like, or molecules like RBCs and plasma to pass because they are large. Okay, I've answered that. Okay, I've answered that size of the slot. Okay, size, so I'll just put size because I'm also using voice, so you're able to write down those answers. So last question is state one common disorder with the kidney. So here, don't just even waste time. We've heard of kidney failure, so there are quite of numbers. There are quite of numbers that will make kidney failure: smoking, you know, injuries, accidents. So sorry, I forgot to put kidney. All right, I'll put just case. So kidney failure is the common disorder associated with the kidney and comes out with different, including diety. You've heard of nephritis, kidney stones, all those kind of things. They'll make the kidney to fail. So now explain how the disorder you've mentioned in CE can be treated. So this can be treated in two ways. Number one is by having a kidney transplant. Okay, kidney transplant. Okay, kidney transplant. Then number two is by using the dialysis machine. So kidney transplant is just a process by which a healthy person that has got kidney donates to the recipient, and dialysis machine is just involved the using of the machine. All right, so that has been me explaining on the explaining on this question that was being asked of 2021. Hope you've gotten something, and hope you've revised on your excretion, particularly nephron. So it's a must. You need to study the nephron, know the function, know the different substances that are there, know how the reabsorption is done in this structure labeled M, know how the urine is corrected until it goes to the bladder. So you just need to know and understand this nephron structure, as well as also the structure of the kidney. For you, it's very important to know that, and especially just understand the physiology of the nephron. So that has been me, Ismail bin Hawa. Thanks so much for watching. Don't forget to subscribe on my channel, as well as don't forget to put that notification bell so that you always receive new videos. Stay blessed, and also anyway, so chab kwa sila, what else do you want na video ya sila. All right, thank you. New Learning Lab and Research.